Hey, sixth grade. Our screencast today is on equivalent ratios, and our objective is I can develop an understanding of equivalent ratios by using tape diagrams to explore the possible quantities of each part when given the part-to-part ratio. So it's kind of a long objective, but really we're just going to be using visual models, tables, ratio tables, and some real-world context to help us develop some equivalent ratios and understand what they mean. So let's look at exercise 1. It's going to ask us to write a one-sentence story problem about a ratio. So you can pause, you can think of any ratio in the whole world, and then write one sentence to describe it. So an example might be the ratio of the number of sunny days to cloudy days. And I'll say in this town is 3 to 1. Write the ratio in two different forms. So I already wrote it with the colon, 3 to 1. You could also write 3 to 1 or 3 over 1. For exercise 2, excuse me, they have a table. So in our table, we have the length of Shani's ribbon in inches, and then the length of Mel's ribbon in inches. And we've already seen in our previous video about ratios that ratio tables can be helpful when we're trying to develop equivalent ratios. So our problem here is Shani and Mel are using ribbon to decorate a project in art class. The ratio of the length of Shani's ribbon to the length of Mel's ribbon is 7 to 3. So in our table, I can already fill in when Shani's ribbon is 7 inches long, Mel's ribbon is 3 inches long. And then I can multiply each of those quantities by 2 to come up with an equivalent ratio. So 7 times 2 is 14, and 3 times 2 is 6. I can also start with our equivalent ratios, our original ratios, 7 and 3, and multiply each of them by another number to come up with another equivalent ratio. So since I already multiplied by 2, now I'll multiply by 3. So 7 times 3 is 21, 3 times 3 is 9. So now I've created 3 ratios, and they're all equivalent to each other. 7 to 3 is equivalent to 14 to 6, and both of those are equivalent to 21 to 9. And we can also draw a tape diagram to represent this ratio. So not only do we have a table that can be helpful, this table up here, but we can also draw our tape diagrams. So when Shani has 7, Mel has 3, and I want to make sure that their 3 kind of line up. So I'm going to make Shani and Mel's first chunk each be equal to 3. But when Mel has 3, Shani has 7, so now the rest of this needs to be 4. All right. Each unit on this tape diagram, each one of these boxes represents something. We know that each unit is a length. If I thought each unit on this tape diagram represents 1 inch, then I can figure out the lengths of the ribbons, right? Because this is 1 inch, 2 inch, 3, 4, 5, 6, 7 inches, and then 3 inches. We could write the ratio as 7 to 3, 7 to TO3, or 7 over 3. But I can use this tape diagram now to figure out my equivalent ratios, because now instead of saying if each ribbon is equal to 1, or each unit is equal to 1 inch, what if I said each unit is equal to 2 meters? Then I have 2 meters plus 2 meters plus 2 meters plus 2 meters plus 2 meters. And I could figure out when this entire 7 units is equal to 14 meters, I could figure out what Mel's is equal to in meters also. So that could help me create an equivalent ratio. I can show you what that may look like right here. So you can go ahead and set up these tape diagrams. The first tape diagram set up here will represent our original problem. So here we have 7 inches and 3 inches, and we wrote that ratio as 7:3. So that's our original one that we started with. The next problem, or the next tape diagram, let's use that 2 meters from the previous portion. So 2 meters, 2 meters, 2 meters. Each of these units is equal to 2 meters. And I'm just plugging in the same number for each unit because then it will help me to create equivalent ratios. So in each of these units is 2 meters. That means this entire ribbon is equal to 14 meters. And this entire ribbon is equal to 6 meters. And so I could write that ratio as 14 to 6. And now the other value that we had on our ratio table was when we multiplied by 3. So I'll go ahead and use a unit that is in a multiple of 3. So let's try 3 inches. When each of these is equal to 3 inches, three times 7 is 21, so that would be 21 inches. And 3 inches, 3 inches, 3 inches, that would be 9 inches. So I would write this ratio as 21 to 9. And like I said before, these values are the same values that we saw in our ratio table right here. So either strategy will get you to the same thinking and same answer. All right, let's look at another problem. Exercise 3 tells us that Mason and Lainey ran laps to train for the long distance running team. The ratio of the number of laps that Mason ran to the number of laps that Lainey ran was 2 to 3. So remember, order matters. Mason came first in the problem, Lainey came second. So Mason ran 2, Lainey ran 3. And the question asks us, if Mason ran 4 miles, how far did Lainey run? Draw a tape diagram. Okay, so we can use the same unit in each of our boxes here to figure out this problem, just like we practiced in the previous boxes up here. Every single number that we put in for the whole problem was the same. So here I have to plug in the same number in each box. And we already used the ratio from this part of the problem up here. Mason ran to Lainey's running was 2 to 3. So here's Mason's 2 and here's Lainey's 3. We use the ratio to set up the tape diagram. And now if Mason ran a total of 4 miles, that means each of these boxes would be 2 miles. And so that's the unit that I'll be plugging in for the rest of the problem. So when Mason runs 4 miles total, Lainey runs 6. So we would write that as 4 to 6. And to answer the problem, Lainey ran 6 miles. So what ratios can we say are equivalent to 2 to 3? Well, if we continued using tape diagrams, we could say ratios equivalent to 2 to 3 are 4 to 6. We could also use a ratio table. So I could set one up, Mason's on this side, Lainey's on this side, and we already know 2 to 3, 4 to 6. So I'm going to start with the original ratio, 2 to 3, and multiply that by the same number to create more. So 2 times 3 is 6, and 3 times 3 is 9. 2 times 4 is 8, and 3 times 4 is 12. So I just made 2 more equivalent ratios. 6 to 9 is equivalent, and 8 to 12 is also equivalent to 2 to 3. All right, and then let's go ahead and do our group practice problems. So for this, you can either screenshot it and then write on your iPad, or you can record it in your notebooks. So Josie took a long multiple choice end of the year vocabulary test. The ratio of the number of problems she got incorrect to the number that she got correct is 2 to 9. So 2 is the number incorrect, 9 is the number that she got correct. If Josie missed 8 questions, how many did she get correct? Draw a tape diagram to help you solve this. For part B, if Josie missed 20 questions, how many did she get correct? Draw a tape diagram. And then finally, what ratios are equivalent to 2 to 9? And describe how to create equivalent ratios. Thanks so much.